For this video, Supermicro sponsored my trip to Supercompute in St. Louis, 2025. Now, you've probably seen our videos on the mammoth rack scale GB300 NVL72 and the B300 full rack systems for the modern AI factory. But many companies are building their software, learning how to leverage bleeding edge software, learning how to leverage this new era we find ourselves in. They don't have, or they don't yet have, a workload that would keep these beasts busy in an AI factory churning out tokens 24/7. Or it's about data governance and keeping data local. So what are the options? Well, you can run Blackwell locally, and that looks way different. There's DGX Station. NVIDIA's DGX Station is really interesting, and I was able to get the inside scoop from Supermicro. In 2025, we're kind of at the end of 2025, and the other thing I've noticed is, the AI factory story from NVIDIA, they've got everything from the very small DGX Spark, of course, but you guys are also showing DGX Station.
Yes, we have DGX Station based.
And Blackwell workstations all the way up to like GB300 NVL72.
Yes.
So, start at the small and then walk me through, but it's all the same software ecosystem. Like if it runs on the little, it'll run on the big.
Yeah, that's one trend that we've seen as well, is like local development for consistency with local development and deployment in a server. So we have Grace Blackwell-based workstation products.
Well, it's, like your customer experience is, okay, we've got the, GB300 NVL72, we've deployed it, we got our $100 million deployment, and then your research scientist goes to deploy something to troubleshoot it, and then they forget about it. And it's like, no, you can do that on a DGX Station.
Yeah, that's true. Yeah, exactly. And then they can test out like basically one equivalent of testing a node. And then we also have the standalone GB 200 NVL4 system, which is kind of like one compute tray out of an NVL72.
Nice,
so
yeah.
That's just some of the things that...
you guys also are launching, it's GB200 and GB300 in the DGX Station configuration. So floating point 64 is the advantage there.
Yeah, it's because of the fact that the B200 generation supporting FP64, still being able to provide that as an option, I think will be helpful in the HPC kind of setting. Yeah.
That's a big deal because DGX Station has multiple different flavors. Supermicro has something truly unique here in the GB200 option. I mean, supercompute is kind of an academic background, an academic context, and a lot of the academic PhD types, they're really concerned with that FP64 performance, and they get it with GB200.
Yeah, definitely. So,
and GB300 is more like the bleeding edge.
Yeah.
I don't think we're going to see another generation after Blackwell where NVIDIA is able to capture more performance because they clawed all the hardware performance they possibly could, and then there's all the software optimizations, like the FP4 with 1% loss.
Yeah, they definitely have prioritized those AI applications with the FP4s, and also a lot of the CUDA core, not CUDA cores, the microarchitecture is streamlined for the AI calculations, in addition to playing well with the expanded HBM3E memory going up to 288 gigabytes per GPU, and I think that sort of density is pretty incredible.
The idea here is to let you run GPUs at a medium-high scale in a local developer context. You can give them something with a little bit more horsepower, where the 1 petaflop of DGX Spark isn't quite enough. You're going to need 20, 50, 100 petaflops of NB FP4 close at hand. Now, Supermicro also has their Super HPC Station.
This is not a workstation. Don't call it workstation. NVIDIA will be mad at you. We call it at Supermicro the Super AI Station.
I think desk side is the term that Supermicro prefers now. Desk side AI compute. And I'm really excited because we get to talk speeds and feeds, how fast is each thing going, but I gotta say, DGX Station is what I'm most excited about because it's heterogeneous memory, but it's unified, and it's 20 petaflops?
FP4 precision.
Well, NVFP4, but it's still. DGX Spark is 1 on a good day. This is 20. That is insane. But it's also got HBM3 plus SOCAM
memory.
DDR5.
Yep.
Yeah. So 4 modules of
SOCAM,
128
LP,
gigs.
DDR5, 4 of them.
Yeah.
This is basically the next-gen AI development platform, replacing PCIe-based platforms and workstations, as we're using the GB300 superchip, the SXM module. This is the first time ever we put an SXM in a workstation tower.
This is a platform that has normal PCIe slots and M.2 and looks like just a really high-end ATX motherboard in a more or less normal looking liquid cooling is pretty awesome standard case. And so it's really exciting that it's 20 petaflops of NVFP4. But you've also got the GB200 version of that, which is 18 petaflops?
18 petaflop. We will have two versions for this station. A GB200 for HPC, because B200 is a better accelerator for FP64.
I will say it is because FP64 is amazing, and GB200 has still got it where it counts in FP64. But GB300 supports a lot of new modern formats that are they're getting wild and crazy on this frontier with AI. So horses for courses.
Yeah, this station is just 1600 watts. It's really an ATX PSU based platform, 42 decibel. A human discussion is just like 55 something. This is quieter than a human discussion. It uses a regular power outlet. You can use it in any office, under or on top of any desk. Perfect for AI development.
Now there's DGX Station and there's Super HPC Station. Super HPC Station has flown under everybody's radar. It is one of the most interesting bits of information to come out of Supercompute 25. It's like DGX Station, but it's based on GB200, not GB300. Why GB200? Well, academics demand peak FP64 performance, floating point 64. That's what it's been since the 1980s.
We are the exclusive manufacturer for this, for GB300 station. And yes, as you can see from here, and then we have, it's a NVIDIA grade super chip with Blackwell GPU.
Yeah, I think this is what a lot of folks that got, you're looking at DGX Spark and it's like, I need something, why doesn't this have more horsepower? Here it is, this is it, this is what you wanted. Yeah. This is 288 gigs of HBM3.
Yep, this is the newest, obviously newer stuff, okay, in the market, and then we are the exclusive manufacturer for this, for GB300 station. And yes, as you can see from here, and then we have, it's a NVIDIA grade super chip with Blackwell GPU. Yeah. So all in one, and the main selling point of this is liquid cool. So closed loop liquid cool. So basically you don't really have to refill that liquid anymore, right? But of course it will dissipate a little bit, but it's a closed loop. And also it's a 1600 watt power supply, and it's an on-prem solution. Yeah. So what that means is some of the maybe financial institutions or education institutions or whatever government agencies, they prefer on-prem. They prefer not to put that data in the cloud. They want to train the AI inferencing on-prem. So this will be a good solution to them, good solution for them. So yeah, obviously this is the newer stuff, and it will be available December. So very close to general availability.
It's basically shipping at that point.
Yes, of course. Yeah, that's right. Yeah.
To give you a sense of scale, let's talk about NVFP4 AI petaflops performance. A single DGX station is up to 20 petaflops of FP4 because it mixes ultra-high performance HBM3E and the slower LPCAMM DDR5. It's a heterogeneous memory platform. A single RTX Pro 6000 Blackwell server card is solidly 3 to 4 petaflops of NVFP4. But you can stack up to 8 of those even in an ordinary PCIe system. Moving on from that, of course, you get the B300. Like GB300 versus B300, DGX Station gives you grace. So you get Blackwell GPUs in, whether you're building an x86 based server or whatever, but DGX Station gives you the 72-core ARM CPU platform from NVIDIA. 72 cores in Supermicro's DGX Station. And you heard that right, it's SXM, which is modular, but it's liquid cooled. Closed loop. So dual 400 gig QSFP, 428 gigs SOCAMM LPDDR5 modules, plus the 288 gigs of HBM3E, and this is fully compatible with the same NVIDIA software stack. So yes, all the way from GB10 to DGX Station, Supermicro's implementation, all the way up to GB300 NVL72, the same software platform. You can run it here, you can run it wherever, it doesn't matter. And you got PCIe connectivity, so you can add in all sorts of experiments, M.2 slots. This is more like I think what some people were expecting performance-wise from DGX Spark. I mean, maybe a little unrealistic on their part, but This looks more like some of the stuff that I think people have been climbing the walls for.
Yes, yes, exactly. We have a lot of inquiries on this. Yeah, so let's stay tuned for the, hopefully we'll get a very hot market response from this one. Yeah.
Nice, yeah.
Yep, thank you.
Now this looks more like a traditional server. I can see RTX Pro 6000 PCIe cards, I can see PCIe GPU. This looks like what I'm expecting, but this is RTX Pro 600 watts. We've got 6 3.2 kilowatt power supplies.
Yep.
But this is just a bunch of PCIe slots.
Yeah, and that's not a bad thing. This utilizes our more of our classic system architecture. Later, we can go check out the front of the system. I'm sure that to some of you nerds out there, it's going to look pretty familiar. But again, it's not a bad thing because they're very easy to service. We have everything, the hot swap, drive bays, and power supplies.
And understand what we're looking at here, it really is just a server with a bunch of server RTX Pro 6000 GPUs in it. For networking, instead of one ConnectX-7 NIC so that we have a GPU fabric, it's just a Bluefield. Most of the AI that you're doing here lives in context of this one machine. Yeah, you still need high-speed networking, but you don't need 800 gigabit times 8 interfaces in this scenario. Understand that brings us to the precipice of the AI factory. Instead of 1 or 2 RTX Pro 6000s, what if you put 8 of those in a system, just a normal rack mount server?
So this is our PCIe GPU system in 5U, and it's pretty self-explanatory in terms of the name. 13 PCIe 5.0 slots, supporting 8 to 10 double width GPUs. This one is designed for the NVIDIA RTX Pro 6000 Blackwell Server Edition that's pulling 600 watts per GPU. And I think that the transition going from its predecessor, which is the NVIDIA L40S, to the RTX Pro 6000 Blackwell Server Edition, I think that it makes it a much more compelling solution for AI applications because of that much enhanced increase in the GPU memory capacity, as well as doubling up on the memory bandwidth, going from GDDR6 to GDDR7. So this system is kind of fully designed to take advantage of that.
768 gigs of GPU memory. Now, unlike the other configurations where it's one, 800 gig NIC or better per GPU, this is more of a normal sort of approach. We've got the dual ConnectX NIC, we've also got the DPU, and so more of your inferencing or more of your compute would be sort of designed to run on a single chassis.
Exactly. So the idea here is obviously you don't have like the 1-to-1 GPU to NIC ratio as you would with the HGX system. So it's not as optimal for things like large-scale AI training, but it is really great for everything else, like running, with the increase in VRAM, you can easily put a AI model fully within GPU memory. And in terms of the networking support, it does support a lot of flexibility to do like 8 GPUs, say, and then 5 NICs, and with 2 CPUs, of course. So those sort of patterns.
One of the fun things with NVIDIA is they support multi-instance GPUs, which means you can partition your GPUs and do that sort of thing. But keep in mind that unless you're building those giant AIs or doing inferencing or training or whatever, you really don't need the unified GPU memory across the entire chassis. Right. It sort of decomposes into the agentic AI and like the usable AI factory. So with 768 gigs of GPU VRAM here, you could run some absurdly large models, but the reality is that customers are going to be running, 4, 5, 10, a dozen, 2 dozen smaller models that are working cooperatively here. We've done demos of that on the channel, and that makes much more sense for this kind of a chassis. And this is much more accessible to their existing IT, much more serviceable, much more normal.
Yeah, I like how you described that, easy to service, manageable, and things like that. So you can do setups like you've done on your channel, where you're running, say, an AI model fully within the GPU memory as a single card, and then you have another card that's used for another type of workload. For example, vector search for retrieval augmented generation.
Yeah, exactly.
Yeah.
Yeah. With RAG, you can have a couple of models that are doing ingestion and like disambiguation. So like to build a knowledge graph, and it's like, okay, we're processing all the documents, we're building the knowledge graph. And then we've got another model that is taking that knowledge graph and adding it to our retrieval augmented generation system.
Yeah, exactly.
Where the rubber meets the road with that is that all of those models are running across a whole bunch of different GPUs, and you don't necessarily need the GPU fabric.
Yeah, exactly. So in cases where it's more about deploying a model that's good to go, then this sort of solution makes sense when you don't need to be scaling out over the network.
I think this would also work pretty well for a lot of fine-tuning use cases. Not every
Yes.
fine-tuning use case, but this would work well for a lot of fine-tuning use cases.
Yeah, I totally agree with that. And it still has some scalability as well, with support for the NICs and the DPUs.
You got 5 or 6 leftover PCIe lanes at the front you can use for storage.
Yeah.
It's fine, it's totally reasonable. And you got another
Yeah, we
configuration.
do. So-
what's the difference with this configuration?
So this is another PCIe GPU system in 4U, and this is based off of the NVIDIA MGX system architecture. So that's kind of like a more prescriptive approach from NVIDIA in terms of standardizing system architecture. So yeah, this is
The name of the game is getting the air in there to cool it.
Yeah, I guess so, right? Because you can see that there's, this is a traditional or classic, right? Classic Supermicro system architecture, where you have a full row of fans that go across here, and then this is an open, grill cover.
We got a lot of fans in the audience of air cooling.
Yeah, those are fully hot swapped too. And then this is the NVIDIA MGX system architecture. Again, like I said earlier, it's a little bit more prescriptive in terms of the design, and it's in 4U. But it's also designed to run 8 of those NVIDIA RTX Pro 6000 Blackwell Server Edition GPUs, as well as additional NICs and DPUs.
So the idea within like it's coming together now. I understand in a way with Blackwell that I didn't understand with the Ampere and Ada generations, in that some of what NVIDIA has in the prescription for DGX and HGX is the developer experience. Like electrically, there's some different arrangements here, but when a developer goes to deploy a workload or build the Agentic AI solution, or it's like, here's my fleet of Docker containers, it's like 7 AIs in a trench coat, whatever it looks like, the developer experience is exactly the same.
Yes. So the good thing is that with both this system and this system, they're part of this AI Factory, Supermicro NVIDIA AI Factory program that we literally just launched like today, where we have a variety of different kind of pre-validated bill of materials going up to cluster sizes of 32 nodes. Of course, Supermicro is able to deploy clusters much larger than 32, but to get enterprises who are trying to deploy on-prem like up quickly, we have these AI Factory packages based on either NVIDIA RTX Pro 6000 Blackwell Server Edition or HGX B200 that, as you described, would lead to a similar developer experience. But within that, there's still options to go with the building block of a 5U system versus a 4U system. And again, once with GPU, with the RTX Pro 6000 Blackwell Server Edition or the NVIDIA HGX B200. But the idea is that these packages are allow you to deploy these clusters as quickly as possible.
I've also noticed that NVIDIA has switched up some of the way that they present that, and it's like, this is the raw level of FP4 performance you're going to get from this configuration, from this configuration, from this configuration, from this configuration. But it's not always about the FP4 story.
Yeah, it is not. It's because a lot of it is, first of all, like enterprises run really diverse workloads. So, any type of time I'm at a trade show talking to attendees, even if they're on something like HGX, they're deploying production grade models, they're doing fine tuning, they're doing like a lot of workload orchestration and all sorts of things, and it's not always, they don't know exactly what they're going to need it for. I mean, they have most of the ideas, but of course, right now we're still very much in the early stages of AI.
Well, it's frontier science. I mean, it's frontier science for everybody. We don't know.
So I think, yes, it makes a lot of sense. I think that anyone buying infrastructure that's such a significant investment is going to want to know what its performance numbers are going to look like. And I think NVIDIA has done a great job at illustrating that with some of their performance figures. And we've partnered with them to try to make deployment as seamless as possible, and just simply making sure that they're getting something that works so they can get online faster.
Yeah, it's turnkey. It's a turnkey solution, and whether you want one chassis or to deploy a full rack that's completely full, or even deploy multiple racks, and it's turnkey at every level.
Yes, exactly.
That's the idea.
Turnkey, plug and play. Those are some words that Supermicro likes to use. So.
Well, you can't do it any other way when you got a yearly product cadence. It's like, oh, we need to engineer this and do that. It's like sometimes it takes more than a year to build a custom house.
Yeah.
And you guys can roll out, a multi-million-dollar,
Yeah.
$100 million custom data center in a matter of weeks or months.
Yeah, and there's like a lot of collaboration that goes on between Supermicro and NVIDIA. There's a ton of validation of the software, things, application software, as well as like the infrastructure software. So these solutions, or the entire AI Factory package solution, is designed to run applications like NVIDIA AI Enterprise, and we test a lot. We do all the way up to L12, which is the cluster level testing, before we're shipping out the systems to the customers, and we were doing that.
Unlike the full B300 system, the networking component is different here. But make no mistake, 8 GPUs with 96 gigabytes of high-speed GDDR7, it's not just upwards of 32 petaflops of NVFP4, it is a full cohesive system, bringing all of this under one umbrella for developers to be able to utilize. The important thing to understand here is the RTX Pro 6000 and DGX Station are kind of on-ramp toward the AI factory. Our brave new world demands mastery of these new technologies. And what I've shown here is the hardware and software where the rubber really starts to meet the road in a truly productive way. And you'd better know that if you're going to navigate this, this new world we find ourselves in. A single RTX Pro 6000 is approachable in a very real sense. You can buy a card, you can put it in a system, and suddenly an enormous amount of modern AI software becomes practical. I mean, you can do that even with a gaming GPU. That's why there's 3 versions of the RTX Pro 6000 with its massive 96 gigs of VRAM. Workstation, Max-Q, and Server. It's because that's where it starts. At the starter end, the software side of things, you've got things like Comfy UI, Llama.cpp, Ollama, open source models, newer inferencing and training frameworks. It's changing every day, every week almost. New models, new research papers, lots of fun things at the bleeding edge. But all of that just works, even starting from a single card. And if you want more performance, you don't throw the system away. You just add another GPU or another system full of 8 of them. DGX Station, well, it kind of sits in a parallel lane. It delivers much higher aggregate NVFP4 performance in a single box. It has tighter integration and a very clear path to NVIDIA's enterprise software stack, but it's still a workstation class experience. You're developing locally, experimenting locally, and learning what actually matters before scale becomes a problem. And that's on the NVIDIA Grace ARM platform, not x86. And that's the key point. Most people don't start by needing the full AI factory. They start by needing capability. They don't need the AI factory to iterate and prototype and to understand their workloads. RTX Pro 6000 systems, even starting with a gaming GPU, you can do those experiments now and then move up to an RTX Pro 6000. These systems will let you build intuition, pipelines, and confidence before the conversation ever turns to racks, power density, or liquid cooling. This is also where software starts to matter as much as hardware. Platforms like Run AI make sense far earlier than people expect. Even with a single 8 GPU RTX Pro system, you can probably leverage Run AI to help all of your workers work together, managing all of their workloads on a system. Because you're orchestrating workloads instead of manually babysitting the GPUs, you're already thinking about the way an AI factory works. And what do you do when you outgrow local hardware or a few boxes like this? You don't have to own the factory, you can rent it. You can burst your workload onto somebody else's AI factory that makes sense. Or if you're really truly generating that workload, you can check out the GB300 NVL72 and tap into the capabilities there. But that's a whole infrastructure question, and you're not forced to build massive infrastructure to start to get some of the benefits from these kinds of things in an accessible way. That's the real story here. RTX Pro 6000 and DGX Station aren't just small AI. They're practical, they're accessible, and they're the path to scalable AI. A way to go from a single GPU on your desk to an AI factory mindset without skipping the steps that actually teach you how to use the power when you get there. I'm Wendell, this is Level 1. This has been a quick look at the hardware that is driving all of the AI mania, from the smallest scale to the largest scale. So, hopefully this insight helps you. I'm Wendell, this is Level 1. If you have any questions or I missed anything or you want to chat about anything that I saw, you can hit me up in the Level 1 text forums. I'm signing out and I'll see you there.